All right, so today we are going to talk about the specific factors model of international trade. That's also a model where trade can lead to inequality. All right, so let's dive in. So the first thing I wanted to remind you of is last time we talked about comparative advantage. And the Ricardian model. Of international trade. So you'll recall with that model, you'll never be hurt by opening up to trade. So the idea is, if there's complete specialization, so if both countries produce exactly one good, so two countries, two goods, right? The minimum model, you need to have international trade, right? If you only have one country, you can't have international trade. You have to have at least two goods, or else if everybody's making the same thing, there's nothing to trade with, right? If we both make cheese, then if I want more cheese, the only thing I have to give you is cheese. So you need to have at least two goods to have international trade. And then in the Ricardian model, we have one factor, but we have different technologies across countries, right? So in that model, what we learned is that if we have complete specialization, so if both countries are producing exactly one good, then both countries will strictly gain. They'll actually be better off under international trade. If we have one country that's specializing and the other one's not, then the country that specializes gains, and the country that doesn't is they're no worse off than they were in autarky, and then the other way around as well. So basically, the message from the Ricardian model is that there's no reason not to open up to free trade. All right. So there's a lot of debate about free trade in the real world, and we want to kind of move on from such a simple model as the Ricardian model to a model where we can talk about the way that trade can affect, say, inequality within a country. All right, so today we're going to talk about, we'll call it inequality in trade. And then the name of the model is the specific factors model. Okay, so what do we mean by a specific factor, and how is that different from the Ricardian model we looked at? Well, the first thing is that we're going to add one more layer of complexity to the Ricardian model. So in the Ricardian model, we had two countries, two goods, and one factor of production, right, labor. Now we're going to have two countries, two goods, but we're going to have two factors of production. We're going to have one factor that can produce one good, and then another factor that can produce the other good, but the labor can't move between the two. So you could think about this as, well, I'll use the classic trade example, guns and butter. So we're going to have some workers that can produce guns, but they have no idea how to produce butter. They can never produce butter. The only thing they can ever do is produce guns. Then we're going to have some other workers, the only thing they can do is produce butter. They don't know how to produce guns, they can never change industries, okay? So that's going to make our results a little bit different from the Ricardian model, because you remember what happens is, if, as I was just saying, you have complete specialization, it means that all of the workers that were working in one of the industries in autarky switched their jobs to the other industry. Okay, in this model, in autarky, if you're working in one job, when you open up to trade, you still have to work in the same job. Okay, you're not allowed to sort of move to the other industry. So that's going to have implications, right? If you're a worker in the gun industry, when you open up to trade, that might be good or might be bad for you. So let's see exactly how that works. Now, before we actually jump into the model, I need to talk about something a little bit technical, unfortunately. So in the, so we have indifference curves, right? And in the last lecture, the type of preference we use, so let's just say this is guns. Actually, let's call this butter. I think that I'm typically going to use the x-axis for butter. And then let's call the y-axis here the quantity of guns. So people are going to be indifferent, right? We're going to have consumers that are indifferent between different bundles of butter and guns. So maybe I'd like to have one gun. This is a bit of a weird example, right? Guns and butter, but it's a classic way of motivating these things. So suppose that I would be just as happy with one gun and 10 butters as I would be with 5 butters and 1.5 guns, or something like that. There can be trade-offs here between these bundles. So we're going to draw the curves that describe indifference between the bundles. All right. So what we looked at last time was something called Leontief or Leontiev indifference curves, and that's indifference curves where the goods are perfect complements. So they look kind of like this. Let's just say these could be Leontief indifference curves, and let me actually draw them with a different color. I'll draw them. Let's draw them with red. So Leontief indifference curves might look like this. So what this says is I want to always have exactly the same amount of guns and the same amount of butter. All right, so it's like this could be 1, 1, 2, 2, 3, 3. And if I have sort of more butter, so suppose this is 3, 3. So it's 3 guns and 3 butters. If I have 10 butters and 3 guns, that's no better for me than it would be if I had 3 guns and 3 butters. So, I mean, there's no reason to sort of add additional goods. You just want to have exactly the same number of both goods, and it's useless to have more of one good than the other one. So an example sometimes is there's some people who only drink tea with sugar, and they only use sugar when they're drinking tea. So, for them, tea and sugar come together in bundles. It's no use to them if they have more sugar than they can use for the amount of tea they have, and it's no use for them to have more tea than the amount of sugar they have. Okay, so this is one classic type of indifference curve. Okay, I can actually just clear the page, it's probably the easiest. Another classic indifference curve, let's do this again, x butter, x guns, is perfect substitutes. So we talked about perfect complements. That's where we always want to have the same amount of the two goods. We can also have perfect substitutes. That could look like this. Let's again. Can I do undo here? Oh, I can. Okay. So perfect substitutes would look like this. They're just lines. Okay. So what these say is that I don't care whether I'm consuming butter or guns. They're the same. I'll just consume the one that's cheaper. If these were, I should have made them exactly 45 degrees going up the line. Then that would say I don't care which good I'm gonna which one I consume. If guns are cheaper, I'm going to consume only guns. If butter's cheaper, I'm going to consume only butter. That's it. Okay. So it's another type of classic indifference curve. But today we need something that's a little more general. Okay. So we're going to need to have. In fact, maybe I should have done this. It's probably easier just to do this. All right. So today what we're going to do is we want an indifference curve that has this sort of classic look. It's going to have this kind of curvy look. So this says that the goods are neither perfect substitutes nor perfect complements. It's like, if you want to, I'd rather have the same amount of both goods, and if you want to give me less butter, say, then you have to give me way more guns. Okay, so there's this trade-off. If you want to give me less guns, you have to give me way more butter. So that's kind of how you interpret these curvy lines. They're kind of a more general indifference curve. We're going to use one particular, easy to work with, type of preference. Okay, we're going to use what's sometimes called Cobb-Douglas. I'm going to try to spell this correctly, but I often fail. Cobb-Douglas preferences with equal weights. Okay, so when we have perfect complements, what that means is that consumers are going to want to consume exactly the same amount of both goods. Right? When we have Cobb-Douglas preferences with equal weights, consumers are going to want to spend exactly half of their wage on each of the two goods. Okay, so it's not that they want to consume the same amount of both goods, they want to spend the same amount of money on both goods. Right? So just to be a little bit more formal about it, that's where utility over, say, I'm going to use xg and xb. I'll have to try to remember to use capital G here. Sometimes I forget. It's going to look like the square root of xg times the square root of xb. Okay. So how can we see that they're going to want to consume the same amount of both? Well, let's suppose that they have a budget constraint. So that says the price of guns times the quantity they consume plus the price of butter times the quantity they consume. has to equal their wage. Okay, you might say, where does this 1/2 come in? Well, you're going to see it here. So the easiest way to solve this kind of problem, consumers are going to want to maximize utility subject to the budget constraint, right? So it's going to be, right now it's a little bit complicated. We have two different variables we need to maximize. So if you've done a little bit more advanced economics, then you might know how to do this with a Lagrangian multiplier, the method of Lagrangian multipliers. That's totally fine. But the easiest way to do it now is with substitution. Okay, so what we're going to do is we're going to substitute out xg from the utility function using the budget constraint, and then we're going to maximize the utility function with respect to just xb. Okay, so let's do that. So we can see here that xg is equal to w minus pb xb divided by pg, right? So now we can substitute that into the utility function. So now we're going to have utility function now just over xb is going to be, let's see here, the square root of w minus pb xb divided by pg times the square root of xb. Okay, so now we're going to maximize this thing. So we want to take, well, let's multiply through by this by the square root of xb. So we end up with, I'm going to take the pg out here just to make things a little bit neater to write. We're going to end up with the square root, the whole thing, of w times xb minus pb times xb squared. Okay, so we have to get a 1/2, right? So that's squared there. That's going to deliver us the 1/2 that we're looking for. Okay, so let's take the derivative of this thing with respect to xb. Okay, that's going to be, and then set that equal to 0. That will be a necessary condition for optimization, so for maximizing utility given the budget constraint. So if we do that, we're going to get 1 divided by square root of pg, and then this whole thing inside of the square root sign here is going to give us a 1/2, and then the whole thing to the power negative 1/2. I'm just not rewriting here what's the argument of the square root. Eventually that's going to cancel, you'll see in a second, so there's no reason for us to write it. I'm just going to cancel it out anyway. And then we're going to get, using the chain rule here, we're going to get w minus 2 pb times xb. We're going to set that equal to 0. Right now, like I just said, this, you can see that this is some stuff that's multiplied by something, some stuff that's multiplied by something. This part that has the minus sign in it is being multiplied by a bunch of constants. These are just numbers. If we divide both sides by just this set of numbers, we're going to end up with 0 divided by something that's not 0, and then this is just going to simplify to 1. So I can actually just cross this whole thing out. Makes my life a lot easier. And then finally, we can come to the conclusion, which is xb is going to be equal to w divided by 2. In fact, let me just write it this way. pb times xb is equal to w divided by 2. So that says the amount that you spend, the expenditures on the good butter, are going to be exactly half of your wages. And then, by symmetry, the expenditures on guns are also going to be exactly half of your wages. Okay, so that's what we wanted to derive. People spend exactly half of their wages on, of their income on the two goods. Okay, so that's what we need here to start talking about this this economy. All right, so now let me describe the economy. So I'm going to describe our economy. Okay, so let's suppose we've got 10 hours of labor. We could think about them as one person, if you like, that has 10 hours of labor, or 10 people with 1 hour of labor. It doesn't really matter. Let's just think about it as one person with 10 hours of labor that makes guns. Okay, so LG is going to equal 10, and let's just also assume that LB is also equal to 10. So we've got one person that has 10 hours of labor to spend on guns, and another person that has 10 hours of labor to spend on butter. Okay? Now, let's suppose that it takes 10 hours to make one gun, and then let's suppose it takes 1 hour to make 1 unit of butter, whatever that is. Okay, so here are our unit labor requirements, right? And you can already see, we don't need to say much more, you can see that this economy is going to produce 1 gun, and it's going to produce 10 units of butter. Okay, so let's assume that preferences are this Cobb-Douglas with equal weights, so that people are going to spend exactly half of their income on each good. Okay, so let's see what each type of person wants to spend their income on, or what their budget constraint looks like. Okay, so let's write the budget constraint for the guns. The budget constraint for guns is going to be one second, I'm getting a phone call. All right, sorry about that, got a phone call. As I was saying, we're describing the economy. We've got gun makers, we've got butter makers, and let's write down the budget constraint of the gun maker. All right, so let's start with the wage, right? So the gun maker, the wage is going to be the price times the number of guns that were made. Well, you can see that the gun maker has 10 units of labor, and it takes 10 units of labor to make 1 gun, so it means that the gun maker is going to have 1 gun to sell, okay? So the wage for the gun maker is the price of a gun, all right? And then, so that's the income. Now, what are the expenditures? Well, it's going to be the price of butter times the amount of butter purchased by the gun maker. Okay, let's denote it this way. So XB is the amount of butter purchased by the gun maker plus the price of guns times the amount of guns purchased by the gun maker. All right. Now, we could rederive this whole optimization problem. We don't have to. We know that when we have these particular preferences we have, 1/2 of the wage is going to be spent on guns, and 1/2 of the wage is going to be spent on butter, okay? So let's see what the consumption bundle for the gun maker looks like. So I'll say gun maker bundle. So here's the optimal consumption bundle for the gun maker. It's going to give the gun maker the highest amount of utility, the bundle they prefer the most, that they can afford with the income they have. Okay, so for guns, I'll do the gun maker here. It's going to be the wage divided by 2, right? That's the amount that they have that they're going to spend on guns optimally. And then you have to divide by the price of guns, right? So it's PG divided by 2, that's the amount of money they're spending on guns, and then PG is the price of guns, so the amount of money divided by the price, that's the quantity, right? So we end up with, the PGs are going to cancel, so we end up with 1/2. Okay, so the gun maker, at the end of the day, is going to get 1/2 of a gun. Okay, that's what they're going to get for 1 day's work, if you like, something like that. Right, how much butter? Well, we can do the same calculation. So it's going to be the butter purchased by the gun maker. Right, that's going to be PG divided by 2 again. That's the amount of money that's being spent on butter divided by the price of butter. Okay, so it's 1/2 times PG divided by PB. Right, now let's look at the butter maker bundle. So if we could write it, so here's the budget constraint for the gun maker. Let's write out the budget constraint for the butter maker. It's going to look very similar. But now the wage for the butter maker, let's think about the butter maker. How much money are they going to make? Well, they have 10 units of labor, and it takes 1 unit of labor to make a unit of butter. So they're actually going to get 10 times the price of butter, right? They can make 10 units of butter, okay? And we know they're going to spend half on each of the goods, right? So let's start with X, maybe B, okay? So that's going to be 10 PB divided by 2, that's the amount that they're spending on butter, divided by PB, okay? So the PBs cancel out, and we end up with 5. So the butter maker gets 5 units of butter. Then let's do, shipping guns. So how many guns does the butter maker buy? Well, 10 PB divided by 2, half of their income, divided by the price of guns. So here we get 5 times PB divided by PG. Okay. So we're not quite done yet, right? We know how much butter the butter maker is going to purchase. It's 5. We know how much 5 units. We know how many guns the gun maker is going to get. It's 1/2. But we don't know what the prices are. Okay. So what can we do to finally sort of close this model at an equilibrium condition? We need the markets to clear. Okay. So now let's talk about autarky. If we're an autarky, maybe I don't really want to move to the next page because then you won't be able to see what's on this page. So if we're in autarky, I'll just write that here, autarky. So there's no trade. We know that the number of guns has to equal 1, right? We've got 10 units of labor, and it takes 10 units of labor to make 1 gun. We're going to make 1 gun. 1/2 is being purchased by the gun makers. It means that the other 1/2 has to be purchased by the butter maker. Okay, so 5 times PB divided by PG has to equal 1/2. Okay, so PB divided by PG, it has to be 1/10. Okay, so and then we can do that. We can reason that way, and then we can do the same thing the other way. The butter maker gets 5 units of butter. 10 units of butter are produced, so it means that the gun maker has to also have 10 units of butter. The way we can do that is we can notice that PG divided by PB divided by times 1/2 is going to have to equal 5, which means PG divided by PB has to be 10. Okay, so PB divided by PG, it's 1/10. PG divided by PB is 10. So PG divided by PB equals 10. From market clearing, all right? From market clearing. Terrible handwriting there. So that means that this has to equal 5, and this has to equal 1/2. All right? So we can see that they actually have a symmetric consumption. The gun maker and the butter maker actually consume exactly the same bundle in autarky. Okay. So now let's talk about what happens when you open up to international trade. And here, I think I might have mentioned last time, when you open up to international trade, from the perspective of a consumer in one country, that's just like a change in prices. So we can think about opening up to international trade as simply a change in the prices that the two factors here are facing, that the consumers are facing when they have their purchasing decision. Okay, so let's suppose that we open up to trade with with a country that's much better at making guns. Okay, so let's suppose that the relative price of guns, so PG divided by PB, changes from 10 in autarky to, let's say it changes to 2 in free trade. Okay, so what we want to figure out now is what happens to the consumption of the two factors. What happens to the consumption of butter makers, and what happens to the consumption of gun makers? Okay, so the first question is what happens to production? Okay, so now they're facing different prices, so do gun makers change what they're doing? Do butter makers change what they're doing? And the answer is no, they don't, because gun makers can only produce guns. It doesn't matter what the prices are, the only thing that they can do is produce guns. Okay, so actually the number of guns that are being produced in the economy is still going to be 1. Same for the butter makers. The only thing they can do is make butter. So it doesn't matter what the prices are, there's always going to be 10 units of butter. As long as there's, if the price is 0, then of course you don't care, then you don't work, right? But as long as there's a positive price for butter, then the butter makers are going to make 10 units of butter, and the gun makers are going to make 1 gun in this economy. Okay, so actually the problem looks very similar. The budget constraints, everything is very similar. It's just we're going to have a different price. Okay, so we can again write out the what did we do on the last page? Let me just flip back here and look and make sure I'm repeating exactly. Gun maker bundle and butter maker bundle. Okay, so let's do the gun maker bundle. Okay, so again, we're still going to get that the gun maker is going to get 1 times the price of guns. Okay, and they're going to spend half of that on guns. Okay, so the XGG, so the guns purchased by the gun maker, it's still going to be the price of guns divided by 2 divided by the price of guns. It's still going to be 1/2. Okay, so that didn't change. That didn't change at all. And then the butter purchased by the gun maker, it also looks very similar. In fact, it looks exactly the same. It's still PG divided by 2 divided by PB. Okay, the only difference now is that PG divided by PB fell. It used to be that that was 10. Now it's only 2. Okay, so we end up with 1, right? Oh, I wrote a mistake here. Let's rewrite that again. So it's going to be 1/2 times PG divided by PB, which we can see is actually now equal to 2. So we've got 2 times 1/2, and that's going to be 1. So if we compare here, the gun maker previous to opening up the trade, they got 1/2 guns, and they got 5 units of butter. Now they get 1/2 units of guns and 1 unit of butter. So actually they're worse off. They get less butter than they had under Autarky. We opened up the trade, and we hurt the gun maker. Okay, let's see what happened now to the butter maker. So that's going to be butter by the butter maker. Okay, so again we're going to have 10 times PB divided by 2. The production didn't change, they're still making 10 units, divided by the price of butter. You can see that that's going to end up with 5. So that didn't change, the same amount of butter consumption as in Autarky. What about guns consumed by the butter maker? Alright, 10 PB divided by 2, that whole thing divided by PG. Alright, so we're going to get 5 times PB divided by PG. Alright, PB divided by PG, that's 1/2. So that's 5/2. Okay, so let's compare that. Okay, previously the butter maker got 5 units of butter and 1/2 units of guns. Now the butter maker gets 5 units of butter and 5/2 units of guns. Okay, so they used to have 1/2 units of guns. Now they actually increased the number of guns they got by, let's see here, 5/2. So that's 2.5. So by 2, right? They got 2 extra units of guns. Now, I'm going to come back to these numbers in a second, but let me kind of show you one way you can think about this sort of economy. Okay, well, maybe actually before I do that, let me just sum up here a little bit. Let me just mention, look what we've done. We started with perfect equality. Gun makers and butter makers were equally well off before we opened up the trade. After we open up the trade, we now have inequality. Okay, so we have butter makers that consume more of both goods relative to the gun makers, right? The butter makers get 5 units of butter relative to the gun makers 1 unit, and the butter makers get 5/2 units of guns, 2.5 guns, relative to 1/2 by the gun makers. So we've got inequality. Not only that though, we've got inequality, and the gun makers are actually worse off than they were before we opened up the trade. Okay, so now we've seen that trade in this case can actually increase inequality and harm some people. Okay, so you can think to yourself, why is it? What is it that's driving this result? Why is it that in the comparative advantage model we had trade always making you at least as well off and sometimes making you better off? Okay, now we come over here to the specific factors model, and you're actually worse off, some people, and we have inequality after we open up the trade. So it looks like now trade is not nearly as good. What's the difference? Well, you know, the only real difference between the two models is we added a factor, right? So previously we had labor that could produce either good. Now we have labor that is specific to one good. All right, so it's the fact that labor can't move between industries. That's what's causing people to be worse off. You know, if these gun makers, if they could make butter instead, you know, they would also be better off. The problem is that they can't. They're stuck. The only thing they can make is guns. Now think about the real world. It's kind of a mix of both things, right? So you have workers that say are textile workers in Denmark, okay, in the 1980s. So Denmark actually had a pretty significant textile industry, and Then Denmark opened up to more trade. There was more trade with Italy. Italy was making cheaper textiles, similar quality, maybe even higher quality, and it basically drove those businesses to die in Denmark. Maybe that's not a problem if businesses die, right? Other businesses can open, but those textile workers, they were trained as textile workers, and it was hard for them to change jobs. Not impossible, like in the specific factors model, but very hard. They had to be retrained, and that was costly for them. So the real world is a mix of these two models. Okay. Now let me just show you. It's an economics class. We've got to draw a graph. Let me show you a way to think about this through a graph, and then one sort of additional insight we get if we look at the graph. Okay. So let's think about what the production possibilities frontier would look like. Okay, for this model. Okay, so let's call this down here quantity of butter produced in the economy, and here's quantity of guns produced in the economy. And I'll start using some colors here. All right, so we know with this economy, we've got gun makers that can only make guns. Okay, so no matter what happens, no matter how much butter is produced, you get the same number of guns, right? So even if there's no butter produced, you get one gun. Even if there's 100 units of butter produced, you're going to get one gun, because we've got these factors that can only produce guns. So how do we draw that? We say we've got one. Let's just make this one here. Oop, I thought that I had blue. Let's say this is one here. The production possibilities frontier is going to kind of come out like this. And it's the same story for butter, right? No matter what is happening with guns, if we've got 1/2 gun being produced, 100 guns being produced, the butter makers can only make butter, and they're always going to use their labor to produce 10 units of butter. So then maybe we have something like that. Okay. So what are these numbers on the axes? Well, this is 1, this is 10. More formally, that's the amount of labor we have in guns divided by the unit labor requirements for guns. Down here, the amount of labor we have in butter divided by the unit labor requirement we have for butter. And look here, I made a mistake. I knew I would do this eventually. I made a lowercase g. We'll have an uppercase g. There you go, for guns. Okay. So when we're in autarky, we've got these Cobb-Douglas preferences with these curvy indifference curve lines. So let's look at what kind of indifference curve we're going to have in autarky. So we know we want to have the highest indifference curve that's going to intersect with the production possibilities frontier. Right? So it's going to look something like this. I got a kiss. Okay, just barely kissed there. All right, so it's going to look something like this. I made it a little bit too linear at the end here. Let me try to make it a little curvier at the end. Okay. So in autarky, we're going to find a price, and this is supposed to be a line, and now this is going to be really difficult for me to do correctly. But we want to have a price where this market is going to clear. Because, basically what happens is consumers are going to be able to consume any bundle on the price line. Like we've got now, that's a production possibilities frontier. We're going to now have a price line. Let's see if I can do this and try to do it somewhat straight. It's going to look something like this. You have to imagine it's going to just kiss right here. And this red line technically should be above the price line, not touching it. So maybe I'll make that more obvious. Erase a little bit here. Redraw. Okay, this is the green line I'm redrawing. Let me draw my red line. It's supposed to be above it. Okay. So it's supposed to kiss right there at the corner of the production possibilities frontier. And it's a little bit ugly looking, but the point is the consumers can actually afford to buy any bundle along the green line, but at this green line, at this price, which as you recall is 10, right? PG divided by PB, the slope of this line actually is negative PG divided by PB, so the slope is negative 10. At this line, the best they can do, the highest indifference curve they can get is the one that is right at their production possibilities frontier. Okay, when we open up the trade, we actually can move that price line. Okay, so now I'm going to have a new price line after opening up the trade. And in fact, I told you what it was in our example. The price line was PG divided by PB is equal to 2. Right, so then we need a line with a slope negative 2. So that's going to look something else. Slope -1 would be like that. Slope -2 is going to be slightly like this. Let's just do it like this. Maybe something like that. Okay? So, production doesn't change. The bundles that are being produced are still here by the economy. But if we had a representative consumer, if we had both of the consumers in our economy consuming the same bundle, then what you can see here is we can actually move our indifference curve to a higher indifference curve. We no longer have to stick on our production possibilities frontier. We can trade, we can send some things abroad, we can make things, send them abroad, and then in return we get other things. So we can actually afford anything along this orange line, and you can see that we're actually going to be able to move up to a new indifference curve that's like, let's say like way up here. Okay, that's like a much higher indifference curve. So in principle, opening up to trade could benefit everybody in this economy. The problem is that you need to have a transfer, right? So how do we see that? You can see it here on this graph. If we had a representative consumer, just one type of consumer that so if we had the guns and the butter makers were consuming the same bundle, you can see here how that would work. That's not what we actually have, right? So I guess the point that I want to make is that, I'll just write them down here as kind of sum up comments. So summing up, so model shows that trade can, 1, increase inequality, and 2, hurt some people. It also shows that, from this last little discussion, but with redistribution, we recover, I'll call it the Ricardian result. Results, trade benefits everyone, at least weekly, right? Won't hurt you. So I guess the question is, how much does the real world, how much is it like the specific factors model, and how much is it like the Ricardian model? And then number 2, how much redistribution do we really see? Okay, so those are the questions that we can think about, and I will stop there.